All right, let's get right into it. Today, we're going to tackle one of the biggest, most fundamental questions out there about artificial intelligence.
You hear it constantly, right? AI is learning. We all say it, it's all over the news. But what's actually happening inside the machine when we say that? It's not like it's curling up with a good book. It's a mathematical process, and honestly, a pretty fascinating one. So let's break it down.
Okay, so first up, what is the core task? At its absolute heart, machine learning is really simple. It's about taking a guess, seeing how wrong that guess was, and then, well, trying to be a little less wrong on the next guess. That's really it. It's just a cycle of trial and error, but on a mind-boggling scale.
So, how does an AI know how wrong it is? I mean, it needs a way to keep score, right? That's where something called a loss function comes in. The easiest way to think about it is like a golf score for the AI. A really high score is terrible, a low score is great. And the entire game, the whole point of learning, is to get that score as close to zero as possible. Okay, let's make this super concrete. Think back to high school math for a second. Imagine you've got a scatter plot, just a bunch of dots on a graph. Your job is to draw the one single straight line that best slices through them. The loss here, it's just the total combined distance from every single one of those dots to the line you drew. If your line goes through every dot perfectly, which almost never happens, your loss is zero. You've won. And that is what we mean by learning. It's the process of the AI itself tweaking its own internal numbers, the slope and the intercept of our line in this case, over and over and over again. And with every single tiny adjustment, it's asking one question: did that make my loss score go down? The whole process is just this relentless quest to nudge that error score closer and closer to zero. Okay, so we know the what, get the loss score down. But now for the big question, the how. How does the AI know which way to tweak its parameters? Does it just guess randomly? No way, that would take forever. It uses a brilliant and surprisingly intuitive algorithm called gradient descent. And this is the classic analogy for it because it's just perfect. Imagine you're standing on the side of a huge rolling hillside, but it's completely filled with a thick, dense fog. You can't see more than a foot in front of your face. Your goal is to get to the absolute lowest point in the valley. So what do? Well, you'd feel the ground beneath your feet, find the direction that slopes downhill the most, and you take a step. That's it. That, in a nutshell, is gradient descent. So, broken down, it's a simple little loop. First, it figures out its current score, the loss. Second, it calculates the direction of the steepest uphill climb, that's the gradient. And third, it just takes a small step in the exact opposite direction, downhill. And then it repeats this process thousands, millions, even billions of times, just methodically taking one step at a time towards the lowest point. Now, you might be wondering, how big should those steps be? A tiny little shuffle, a giant leap? That's controlled by a super important setting called the learning rate. And getting this one number right is absolutely crucial. It can make or break the entire training process. And here's why it's such a delicate balance. If your learning rate, your step size, is too high, you're taking these huge, clumsy leaps. You could literally jump right over the bottom of the valley and land on the other side. Then you jump back and just end up bouncing from side to side, never actually finding the minimum. But if it's too low, your steps are ridiculously tiny. You'll get there, sure, but it could take an eternity. So that simple walk down a smooth valley, that's the textbook explanation. And for a long time, it's pretty much what we all thought was happening. But here's the twist. Recent research is showing that for the massive neural networks we use today, the journey is much, much stranger than that. And this quote from a recent paper out of MIT really gets to the heart of the mystery. It basically says, we're still figuring this out. The internal world of a learning AI is, in so many ways, a new frontier, and we're just now starting to draw the maps. So as researchers are mapping this new frontier, what they've found isn't a simple valley. It's a completely different kind of landscape, one that's defined by these long stretches of nothing, followed by sudden, dramatic progress. So let's take that simple analogy we had of just walking downhill and realize that for the huge models powering things like ChatGPT, it's just not an accurate picture of what's really going on inside. The new, more accurate analogy is way more epic. Instead of a simple valley, imagine the AI is navigating a bizarre, high-dimensional mountain range full of all sorts of strange features. So what does this journey actually look like? Well, for long, and I mean long, stretches of the training process, it looks like nothing is happening. The AI's loss score just stays flat, as if it's wandering across some vast empty plateau. Then, suddenly, it finds the edge of a cliff, and the loss score just plummets. It learns more in that one instant than it did for thousands of previous steps.
And this weird behavior has a name. Researchers are calling it the saddle-to-saddle dynamic. The AI isn't just walking steadily downhill. It's moving from one of these flat plateau areas, a saddle point, to another, and its journey is punctuated by these incredible leaps in understanding.
So, as we wrap this up, what have we learned? We've seen that our own understanding of how AI learns is, well, it's learning. It's evolving right before our eyes.
So let's recap. We started with the classic model, that simple, steady walk downhill called gradient descent, which is still the fundamental engine. But we've discovered that in practice, for these huge modern models, the process looks more like a strange journey across plateaus, ending in sudden leaps of progress. And the most crucial point is that researchers are actively mapping this new, bizarre landscape right now. And this leads us to a final, fascinating question. The old, simple model gave us the incredible AI we have today. So by truly understanding this newer, stranger, saddle-to-saddle reality, what kind of intelligence might we build tomorrow? What happens when we finally have a complete map of that hidden world? Thanks for joining me for this explainer.